Hello, this is the Heretic again. On our last discussion, I was going over the details in regards to what some of the forbidden topics, forbidden knowledge, on why I won't be disclosing all things discovered in the heretical physics journey. And that's just more of an ethical and discussion. And I said at the end of it, something to the effect of, don't worry, all the other stuff you'll learn is much more valuable. Now, you're probably saying, well, he's full of it. What could be of use? And I have ran into a touch of difficulty trying to find a way to describe it without being overbearing. See, in the first year of the heretical physics discoveries, I discovered over 50 groundbreaking, many of which Nobel-worthy discoveries. I'll say that again, 50 discoveries. Among those discoveries, we'll cover in just a moment. But that list of discoveries is the solution to properly solving physics problems from their modern physics jail of not understanding, not knowing, or as I like to call voodoo. Much of what you would call the hard science of quantum mechanics is poorly put together. It's non-deterministic and has giant holes in it. But me saying that doesn't mean anything to you. You know what you lose when you pull up quantum mechanics, but it's all you have, so you deal with it. Well, I don't have that problem. The reason I don't have that problem is heretical physics is by its very nature derived from classical physics theories. And if we can't get to a concept using a series of steps, we don't do it. But that's more in the philosophy, which I'll get to later. What I want to go through now is give a basic understanding of how we'll present this information. The concept in heretical physics is to teach one basic set of changes to the modern physics understanding and move that to teach new concepts and new ideas. Then leveraging those discoveries to teach new things. And it becomes a virtuous cycle. So it also means that you can't just go out and learn one topic and expect that that topic is completely knowable by one simple lecture, by one simple understanding. The information is layered. And if you don't understand the basic concept in the beginning, you're sure to be lost by the time you get to a more complex topic. Now, how do I illustrate this? Well, of the 30 lectures, about somewhere in the middle of the range is a comparison between the quantum mechanics model of the helium atom and the heretical physics version of the helium atom. And the reason that that's important is that my version of the helium atom is a more detailed, better model. But most importantly, that model is derived to have a radius equal to 0.385 of the hydrogen radius, both of course being in the ground state. Well, quantum mechanics, when done with large supercomputers, can calculate it only to 0.6 the size of the hydrogen atom radius. Now what makes this important is my value matches the known measured result of 0.385. Quantum mechanics cannot explain why they cannot get the correct answer. In fact, many people have said, well, the measurement must be wrong. No, it's actually not. Is that quantum mechanics hands you failure by its basic theoretical design. But that's at a different level. What we want to discuss is how do you get a model, working model of helium? Well, to get that working model of helium, the first thing is we need to have a understanding of the three-body problem of the nucleus and the two electrons and how they move and interact with each other in a way that does not cause the system to be unstable. Now, to do that, we also need to have an understanding of spin. We need to have an understanding, of the electron spin. We need to have an understanding of the nucleus. In fact, you'll learn through theoretical physics that we really need to know a lot more about the structure of the nucleus to fully understand and appreciate the features of the atomic structure. Now, to understand the nucleus, or the alpha particle, we needed to create a detailed model. And to build that detailed model, we needed to first get an understanding of the strong nuclear force and how that interacts to bind two deuterium modules together on an inverted offset, and how their spins are opposite to bring a total spin of 0. Now, with each deuterium, we have to then study the weak force and its interaction on the neutron binding to the proton, but more importantly, the internal structure, then, of the neutron. And with that in mind, we needed to understand what is an antineutrino. We have to understand the whole life cycle, from birth through its release of all neutrinos. We need to understand that a neutrino, and this isn't really going to help you much, but it is basically a displaced magnetic flux. Now, that spherical magnetic flux is something that doesn't make much sense until you understand the formation and building of both the neutron and deuterium, and then that decay. So we have to cover the decay of a neutron. We have to cover the formation of that neutron. And in doing that, we have to go through the astrophysics of why a magnetic field is needed to convert a disc-shaped set of gases, mainly hydrogen, and convert it into a spherical star. We also have to cover the complete nuclear structure of deuterium, how it relates to spin, and how it relates to several famous experiments, and how that data from those experiments were improperly used. But even with the full structure of the nucleus, or of the alpha particle, we also need to have an understanding of how hydrogen worked, because the hydrogen model is the template we use to do the helium model. Now, the hydrogen, just being a simple electron and proton, you would think would be easy. Actually, the lectures that describe how that works take about 4.5 to 5 hours. And the reason for that is rather simple, is that first you have to describe how energy levels occur, how you get to both the up or down spins in the 1s orbital, how the 1s orbital becomes a sphere, how the basic motion in the 1s orbital is actually a rotating orbital structure similar to a planetary motion that is flipping. To understand that, you have to be able to construct a system where the electron orbits the proton but does not lose energy by emitting photons, because the electron is not moving through the field, but instead the whole system is moving. And to understand that, we have to displace the Heisenberg uncertainty principle versus our model. And beyond that, we need to go into how hydrogen forms, how that electron starts approaching the proton and purposefully misses and goes into a semicircular orbit. Now, all that being said is that we then need to know how just a particle, a proton, for example, how it is perceived as it moves through space and time. It is not just a particle or a point charge. So we have to go through how it interacts with other materials, leading to a detailed discussion of wave-particle duality and providing a complete solution for wave-particle duality. And that solution also shows why the quantum mechanics description of whether could be a wave or a particle is completely wrong. In fact, no discussion from a quantum mechanics standpoint has been even close to correct. Now, with all that being said, we still need to go to what is a proton and what is an electron. And that's where we have to begin. We have to begin with particles not around each other, not doing anything. Now, each one of those steps I bring up is a lecture, either in part or mostly in full. And without just properly defining what this particle is, you will get the next step wrong. That's our big problem in modern physics. They got the basics wrong. And once they got the basics wrong, every error propagated more error instead of having the right answer down here. Things got more complex and further away from the truth at each step. So, how do we solve this? Well, the first thing we do is we need to start providing some basic information and start you off with what happens when a particle, charged particle, moves through space and time. Now that will be one of our next topics, so that we can go over the basics of what is seen as something moves. Thank you very much for your time.